Okay, so here we go. This is our final video on the basic arithmetic with complex numbers. Remember, we're treating division as its own thing because division is different than what we're typically used to. It's a little more complicated, whatever. But we've talked about how to add, we've talked about how to subtract. We've spent a lot of time talking about multiplying between the original video I made plus the second video that had examples in it. And now we're going to talk about exponents. And again, we're going to just focus on exponents in this video. We're going to do a couple different examples with exponents, including kind of like I did with a previous video where I showed you FOIL with multiplication. In this one, I'm going to show you some of the shortcuts that we've learned with polynomials and exponents and how they might apply when we're working with complex numbers. All right, so with that said, let's go ahead and get started. Learning objectives haven't changed. We're focusing right now just on this last piece, how to deal with exponents when we're doing complex numbers. Okay, so let's get started. First of all, we're going to do an example that's exactly the same as what we, or the same type of problem is what we did in my original video, a problem where we just simply turn it into multiplication. And then once we get the multiplication there, then we'll use double distribute to finish. So that's where we're going to start, okay? And that's the process that I outlined in the first video. So this should just reinforce that process. Now, in the second example, we're going to turn it into multiplication, and then I'm going to use FOIL for those of you who are people who like FOIL. So you'll see an example of that in example number 2. And then in the third and the final example for this video, we'll talk about the shortcut that we've learned to deal with perfect squares and how you might use that shortcut to help you with complex numbers. All right, so with that said, let's begin by taking something like 4 minus 3i and squaring that. Okay, and we're going to do this with the same process that I outlined before. There's no shortcuts. This is just a full-blown process, the most general way to do it. So the idea is, first I'm going to rewrite it as multiplication. That's my first step. We've seen, or I've talked about many times, that for me personally, when I multiply, I don't like to multiply where this is a minus sign. So I'm going to turn this into plus a negative 3. That's going to let me keep a plus sign in the middle of my double distribute. And now that's what I'm going to do. So I'm going to take this first thing as a single unit, and I'm going to distribute that first thing to the 4 as a unit. So I'm going to get that whole first thing times a positive 4. Now, because I turned this into a plus sign, that lets me keep a plus in the middle. And now I'm going to take this whole thing and distribute it to the imaginary part, to the second part, to the negative 3i. So I get that whole first thing as a unit times the negative 3i from the second thing. So there's my first distribution. Now I'm going to go through the second distribution of my double distribute and distribute the 4. So 4 times 4 gives me 16. 4 times negative 3i gives me a negative 12i. I still have that plus sign that hasn't gone anywhere. And now I'm going to distribute the second, or the double distribute, from this piece. So a negative 3i times a positive 4 is going to be a negative 12i. A negative 3i times a negative 3i will become negative 3 times negative 3 is a positive 9. I times I is I squared. Okay. So now we know, we've talked about many, many times, the I squared is the same as having a negative 1. So this is really 9 times, not I squared, but 9 times negative 1. All the rest of this I haven't changed yet. That's all still the same. So I hope it's okay. I turned this plus a minus into just minus. I hope that's okay with everybody. Negative 1 times I is going to turn this piece into a negative 9. So what I really have is 16 minus 12i minus 12i minus 9 is what I've got. And now to finish, I'm going to combine together my like terms. So a positive 16 and a negative 9, those are my real parts. They combine together to give me 7. And a negative 12i and a negative 12i, they will combine together to give me a negative 24i. And that will be my final answer. So this is a second example. Whoops, sorry. This is a second example using the full double distribution method. All right. Now, in this next example, what we're going to do is, again, turn it into multiply. That's the first thing we're going to do, just like we did before. But then to multiply for this one, I'm going to use FOIL. So for those of you who like to use FOIL, I'm going to use FOIL on this one instead. So let's suppose that I have something like a -5 plus 20i, and I'm going to square that. We're going to get some big numbers in this one, but that's okay. We can handle it. We've got a calculator if we need it. All right. So the first thing I'm going to do is turn it into a multiply. That's the same step. Basically, no matter what method I'm using, that's my first step, is to turn it into a multiply. Okay, so now when I multiply this, my F stands for first. So that's the thing in both parentheses that comes first. That's a 5 times 5. So I'm going to multiply 5 times 5 to get my F. 5 times 5 is going to be a positive. Negative times a negative is a positive. 5 times 5 is 25. So that gives me my first piece. O comes next. That's the parts that are on the outside. So if this is the middle, then the outermost part here is the -5, and the outermost part here is the positive 20i. So that becomes my next piece, is I'm going to multiply the -5 times the positive 20i. So -5 times positive 20 is going to be a negative 100i. Negative 100i. All right. Now, that brings me to the innermost parts, right? So the I is for the insides, the innermost parts. So the innermost part, this is the middle, the negative or the positive 20i, that's in the middle here. The -5, that's in the middle here. So these are what I'm multiplying together for my I. So a -5 and a positive 20i, we're going to get a negative 100i again. And then last but not least, I have my last parts. Okay, so the things that come last, so that's the 20i that's here and the 20i that's here. So these are my lasts. When I multiply 20i times 20i, 20 times 20 is going to be 400, and I times I is I squared. So there's what I would end up with when I do FOIL. And now from here, everything else becomes the same. I squared is the same as multiplying by -1. So this 400i squared becomes a 400 times -1, and that's equal to a -400. All the rest of this has stayed the same. I haven't messed around with any of the rest of this. So a 25, a -100i, another -100i, and now this positive 400i squared has become a -400. To finish, I'm going to combine together my like terms. Positive 25 and -400 are going to be a -375. And a -100i and a -100i will combine together to be a -200i. And there is my answer. Okay, so this is a second example using FOIL instead of double distribute. Okay. For our third and final example, what I'm going to use is the shortcut that we learned for perfect squares. Okay, now this was the shortcut that when we did it back with polynomials, only a few of us bothered to learn this shortcut. Shortcuts are always optional. You never have to learn shortcuts. So if you never learned the shortcut for perfect squares back, perfect squares. If you never learned the shortcut for perfect squares back when we did polynomials, then obviously you're not going to learn it now either, probably. So you can probably just skip this part of the video. But if you want to, that's up to you. So the rule the perfect squares worked with, let's just review the rule. The rule was if we have something and we square it, what you end up with is the first thing squared, the second thing squared, and in the middle you get those two things multiplied together times 2, and you keep this sign. So a plus sign if it's a plus. If it was a minus, you would get a minus sign. because you keep that sign in the middle. So that was our shortcut rule. If you learned that shortcut rule, then great. If this sounds foreign to you, if you don't remember this at all, then just stop the video right now, okay? But if you remember this shortcut and you want to use it, then let's take a look at how that works with imaginary numbers or with complex numbers. So let's finish by saying that I have 6 minus 7i, and I'm going to square it, okay? So in this situation, the thing that comes first is a 6. So I'm going to end up with this thing having a 6 that's squared. Remember, anytime we're plugging into a formula, we always use parentheses. So a 6 that's squared. We're going to keep this sign. So the sign is going to be a minus. So minus. It's going to have a 2. And then we're plugging in a 6 right here. So a 6 right here. Okay, so that's the first part. The second part is a 7i, right? So this piece that comes next is a 7i. So everywhere there's a b, we're plugging in a 7i, again, using parentheses. So 7i plus 7i squared. Okay, I guess if I'm color coding this, the part that's in black here, that's the part that's just coming right from the formula. The part that's in red and green, that's where I'm getting from the problem. Okay, so now we go through and we simplify each one of these things. So 6 squared, that's 36, minus 2 times 6 is 12. 12 times 7, that I don't remember what 12 times 7 is. So 2 times 6 is 12, times 7 is 84. So this middle part becomes an 84i. And then here I'm going to get a 7i squared. So 7 squared is 49, and then times I squared. So I have to change this into a -1 and finish this just like before. So this thing becomes 49 times -1, which is really just a -49. All the rest of this stays the same. 36 minus 84i. 36 minus 84i. And now I can combine together my two real parts. 36 and a -49 is -13. And there's my answer. Okay, now that gives us an extra example of each of the other methods. If you prefer doing double distribute, then our first example gives you another go around of that. If you prefer FOIL, our second example shows that. If you learned the shortcut, our third example gives that. The one thing that I will say to notice is consistent, no matter which method you're using, is you're having to deal with this I squared in the middle of the problem. That I squared creeps into every one of them. And then at the end of the problem, you're having to combine together some like terms, okay? And those like terms creep into every single problem. So there we go. That is our last example on the basic arithmetic with complex numbers. Thanks for watching. Have a good one.